Okay, welcome Jeremy and welcome Caledon. Thanks for coming. Hopefully a few others will pop on in. The plan today is we're going to be going over confidence intervals. So we're now moving out of tools to do statistics and we're moving into doing statistics. So from now on, everything we do is an application. And we're going to learn about what applications people do and we're going to do them. That's the idea. So what we're going to do today is we're going to do confidence intervals. And I'll talk about that, and I'm going to do that with an example. I'll let you know. Just to let you know some things that are coming up, things that happened. Your online exam was finished yesterday. Hopefully you did okay. It was pretty long, but hopefully it felt like the homework, which will not be like the midterm and the final. The midterm and final are written exams, so not at all like the homework. A lot of writing, more like the discussion posts are supposed to be. So in terms of studying, it's a little different way of doing things. And I wanted to bring that up because your exam is in 2 weeks from Wednesday, must be taken. We're in week 6 and it's in week 8. By next Wednesday, so in 9 days from today, today's Monday, you must make sure that you have the midterm information quiz completed if you haven't done that already. And that is all about finding proctors. So you go find a proctor and you let me know who your proctor is and when you're taking it. And then that's great. And you have to do that by next Wednesday. You could do it earlier, that's fine. One person's already done it, which is fine also. So just let you know that's coming up. And also the midterm is a big, big part of your grade. So you want to take it really seriously. So that's the next big thing coming up. The project isn't for a little while, but we might talk a little about today, just a tiny. The main thing is make sure that you have a partner for project 2. So it's time to start thinking about that, is make sure you have a partner. You are welcome to use the same partner as you use for project 1, but it is not a requirement. And make sure that if you did have a partner that worked out, make sure the partner's still in the class. We have lost a few people. So make sure that you get that going. And again, just like before, before we had the project 1 discussion board, and that was like the place to look for partners. And now what we have, any guess? Instead of the project 1 discussion board? Yeah, project 2 discussion board. Okay, no surprises. I decided a while back, I think about 2 years ago, that I used to only have 1 discussion board for the projects, and it just became too long because it's a big place for people to pop things in. So that's why now I have 1 for each, and that way you don't get overwhelmed with the number of discussion posts. So the project 2 discussion forum or board, that's where you go find more partners, where you ask questions about it, et cetera, et cetera. Also post your idea, but we're not quite ready for that yet. Probably next week I might talk about the idea. So that's about the time to start thinking about it, but you have a while still. But right now it's time to start making sure that you know who your partners are. So that is the plan. So are there any questions about anything from the class? So welcome Shane and welcome Pooja. Any questions about anything? Okay, if there's no questions, I thought I would bring in the big happy current event of the week, which is? So it's the happy current event of the week. At least happy to most people, not all people. Trump won. Pooja, that might be happy to you, but it might not be happy to others. So, so no. All right, let me pop it up, and then I think you'll all agree that it's the big happy thing of the week. Let me go find it. All right, do you agree this is the happier thing of the week than talking politics? Okay, so the CBS did a poll, And the question is, what do Americans prefer for a Valentine's Day gift? And that's a big question. And CNN does not know what all Americans prefer, because that's not ever possible. Hopefully you've got that down from our class, is that you can never find out about everybody. So what you do is you do a poll. And now we're going to move into really understanding how to use statistics to truly understand a poll. Okay, we did in project 1, you took a poll, you took a survey, and you learned about your sample. But what you didn't learn is how to talk about how good an estimate the sample is for the population, because you can't get the population. So you want to do what is a sample, but then how confident you are about your numbers from the sample that it represents the population. Does that make sense to everyone? Okay, and one of the things we talked about in the first week of class actually was that you have to have an unbiased sample. You have a biased sample, forget it. It's pretty hard to be confident about anything. But even if you have an unbiased sample, we talked about how big a sample size you might want, because again, you can't ask everyone. There's way too many Americans to do a survey. But you can ask a group, and let's look what they did. So what CBS decided on was that flowers make the best Valentine's gift, according to the latest CBS News Sunday Morning Pulse poll. Okay, of Americans surveyed, 50% chose flowers. Okay, so do you think that the majority of Americans think that flowers are the best Valentine's gift? What do you think? Majority means over 50%. Okay, so sure, but here's the problem. This is a sample, and then later on, they go here and they say that they surveyed 1,008 adults nationwide. Okay, and remember, there's over 300 million people nationwide, definitely over 200 million adults nationwide. So there's a small chunk, and we're going to make the assumption that they didn't have a big bias. I don't know for sure, but they may not have. I'm not sure how biased it is when it comes to asking about Valentine's gifts. Maybe not. Okay, so, but still, even then, the question is, 52%, well, maybe that fluctuates below 50% because 52% is the sample proportion and not the population proportion. And the population proportion is different than the sample proportion. Hopefully you all understand that, right? Now, how do you measure how different the sample proportion is likely to be from the population proportion? And the hint is, think last week. Any thoughts? And while you're doing that, I'm going to write some things down. We have n equals 1,008. We had our p hat was 0.52. That's the main thing we need. So do you remember what we did last week that helped us decide how different the sample proportion is likely to be from the population proportion? Do you remember that? What did we look at? You can all jump in at once if you want. Jeremy, any ideas? You're all being kind of quiet. No, not sure. Kaladin, any ideas? Okay, not sure. Okay, so let me remind you what we did in that last week, because it was really important. And that was a central limit theorem. And if we look at this, and I think now that we got the numbers, 52% is the sample, and our sample size was 1,008. That's all we need, actually. And we're assuming, again, everything is unbiased and independent. So now what I'm going to do is I'm going to do some writing. So let me go and so we have a central limit theorem. Now, first thing, let's do some checking. First thing, NP is equal to 1008 times P was 0.52. Because that's what they said in the survey. And that is not very hard to do on a calculator. So let me pull in a calculator. So 1008 times 0.52. I'm going to round to the nearest person, which is 524. Okay, and then NQ is equal to 1008 times 0.48. Q is 1 minus P, or the proportion who don't think that flowers are best. And that is what? That is about 484. Any questions on that? Okay, what's important about these two numbers, 524 and 484? Do you remember from last week? Not sure? Any ideas?
It meets the CLT.
Yeah, that means we can use a CLT because they're both bigger than 5. A lot bigger than 5. Do you agree? So both bigger than 5. Y'all agree? I hope you know that 524 is bigger than 5 and that 484 is bigger than 5. Okay? And notice this is a yes-no question. The question is basically, do you think that flowers are the best gift for Valentine's Day? Okay, so then we need some more stuff. If it's bigger than 5, let me draw. We right away can, ooh, that was bad. Try again. That's a little better. We know that we have an approximately normal distribution. The mean is going to be 0.52. Do you remember that? Okay, the standard deviation, that was sigma sub p hat, was the square root of 0.52, which is p, times 0.48 over 1008. Any questions on that? All right, well, if I do that, let's do that. SQRT, I'm just going to type that into Google and let it do it for me. 0.52 times 0.48 divided by 1008. And I get 0.0157 about. Any questions on that so far? So now what I want to do, here's the way it works, is that if you're doing just some kind of social thing, anything in social science, what we're going to say is we want to make sure that if I draw the following picture, like so, that this area, or the probability of being in between these two numbers, is 0.95. And that's called a 95% confidence interval. And 95% is kind of the agreed upon number for all social science. Okay, well, now we know how to do this. We could use the inv norm function. Notice if you have 0.95 in the middle, you have 5% outside or 2.5% to the left. You could do inverse norm, but I want to show you a different way. Any questions so far? Okay, so now let me show you the different way. I'm going to go to the calculator because now it's a bit newer. Okay, so here's the calculator. Let's clear whatever I had last time. And what I'm going to do is I'm going to go to stat. Then I'm going to go to tests. Okay, and we have not done tests yet. I want to let you know something really important. The rest of the course, and we're halfway through right now, that's all we're doing basically. And you'll notice there's a whole long list of tests down here. So it keeps going and going and going. I'm not talking about all of them today, but what I am going to do is talk about the one I care about, which is one prop z int. One, because there was one question asked of one population, and prop because we're talking about proportions. The question is a yes or no question. Z because NP and NQ are both bigger than 5, and int because we're doing a confidence interval. Any questions at all about what we're doing here? Okay, then I hit enter. And different calculators are a little different, but most of them ask this. They ask for X. X for the number of people who said yes. Now, if you remember, NP, which is the number of yeses, was 524. N was our sample size, which is 1,008. And then sea level has nothing to do with being near the ocean. C stands for confidence. This is the confidence level. And 0.95 is correct, so that's the default. And then I'm going to hit calculate. So I'm going to stop for a second. Any questions? Any questions at all? Okay, so let's hit calculate. Okay, and there it is. Sea level is the confidence level. So the idea is, remember that normal curve that had 95%? That was the sea level, 90.95. Because we wanted to say, we want to be 95% sure. And that's good enough for us. This isn't like the end of the world. You know, if we're talking about, you know, a lot of people dying because of what we're deciding on, you might want to be more confident. But if you're just talking about, you know, publishing in a CBS news station what people want for Valentine's Day, 95% is plenty. Does that make sense, Jeremy? Okay, and in our class, we're going to stick to 3 levels. 95% will be standard, and then we'll also have 90%, and we'll have 99%. So 99%, if you really want to make sure you're right. 90% is if you don't really have time to do a big sample and you just want to get some results that are useful, even if you've got a 10% chance of being wrong. That make sense? Okay, so what I get, I'm going to keep 2 decimals. That's kind of the easiest to talk about. 0.49 to 0.55. And that's the confidence interval rounded to 2 decimal places. Okay, so now that I have that, what I'm going to do is I'm going to go do some writing to interpret it. So let me state what I'm talking about. So interpret the confidence interval. Okay, sometimes I'll ask you to interpret the confidence interval. Sometimes I'll say, what are the results? That's the same thing. And what we can say is that with 95% confidence, the population proportion, okay? Or even better with percents, it's a little better, with 95% confidence between 49%, because 0.49 is 49%, and 55% of all Americans, not the sample, but the entire population, prefer flowers for Valentine's Day. Any questions on that? Any questions? Okay, so that's pretty much what we can say. Now notice, if you look at this, 49% is less than a majority. So it may not be over half, it may not be a majority. Does that make sense? But we could say that we're 95% confidence is somewhere between 49% and 55%. And that's the key, and that's what we're going to be doing. That's what we care about. One more thing that is talked about, notice that our p hat was 0.52, 52%, and 49% and 55% are each 3% away from 0.52, right? 52 plus 3 is 55. So the margin of error is what it's called, is plus or minus 3%. Any questions on that so far? Okay, here's the next thing. Is what if I said, instead of interpret the confidence interval, well, let's interpret that number 95%. What does it mean to be 95% confident? Sometimes we'll say interpret the confidence level. Okay, which is not that different in word, you know, a lot of the words are the same, but it is very different. It's not the same as the interval. The level is a 95%. And that's a chance of something happening. It's a probability. And here's how we do it, is that we can say is that if, now we're going to go to the central limit theorem, because that's what we used. Okay? If many samples of 1,008 Americans are surveyed. So let's suppose that we're in the business of conducting surveys. So today we do this survey, the next time we do a different survey. We're going to keep doing surveys over and over and over again. Then you can think that some of the surveys are going to be good, and good meaning that you actually said this 49 to 55%. So if the true population proportion is in there, then I'm going to call it good. On the other hand, if it's not, then it's a bad one, right? Because we were wrong. So if we look at all the different samples of 1,008 Americans that could be surveyed, each of them would result in a different confidence interval. And we can say 95% of these confidence intervals will contain the true population proportion of all Americans who prefer flowers for Valentine's Day. Any questions? Any questions on this interpretation? I want to warn you that there is no short way of writing this. So if you think you can, you're wrong. You know, don't try. There's different ways of writing it, but there's no short way. So when I ask you to interpret the confidence level, you need to really write it out. Okay, it's a lot of writing. Okay, any questions on this? So just to let you know, the next few weeks is a lot of writing for, you know, the discussion post, which is modeling your midterm. So you're going to expect to be doing a lot of writing. Practice the writing. Even though the assignments online for just the homework type assignments, those are, you know, a lot of multiple choice stuff, because it's not going to be able to read to see if you wrote it right because it's a computer. Practice writing it out. Don't just click which one is correct. Try and write it before you read it, and then you'll do a lot better for succeeding. Any questions at all on this example? No questions? Okay, so let me, I'm going to erase this, and we're going to do another type of example that's actually really important. Let me grab it. There we go. Okay, so now let's suppose that you want to conduct a survey of college students to see what they prefer on Valentine's Day. If you want a margin of error of no more than plus or minus 3%, how many students should you survey? Any questions on the question? Any questions? Okay, this is very different than anything we've ever done before in class. Okay, now we actually want to find out how big a sample we need so that we get a small enough margin of error, which is different than being able to use a central limit theorem. This is to make sure we have a small enough margin of error. And what you need here to be able to do this is you need the formula. And there's a couple formulas. One is the following. First, it's an n, because we want to do how many, that's a sample size, is equal to p, which is our best guess for the proportion, times 1 minus p, which is the best guess for the proportion of people who don't say yes, times z over e squared. Now, you probably don't want to memorize this formula, so on midterm, you probably want this on your note card. Any questions on reading the formula first? My guess is not all of you know what the letters represent. What do you think? Y'all know what each of these letters represent? You had a feeling you didn't know all of them. Okay, P is a proportion of yeses. 1 minus P is a proportion of no's. Z is the Z value corresponding to the level of confidence. Okay. And I guess I didn't write that, and I need to. Sorry about that. So if you want, I lost it. You want a, let's say, 95% confidence interval. I did forget to mention that. So Z is going to be the Z corresponding to that 95% confidence interval. And I'll show you in a minute how to get that. E is the margin of error. So let's do the easy stuff first. So what we can say is that P is equal to, well, I'm going to use 0.52. That's my best guess because that's what they got for America. So let's use that. Sound good? 1 minus P is equal to 0.48. And we know E is equal to 3% or 0.03 because that's what 3% is. The plus or minus doesn't matter because you're squaring it and the negative will go away when you square it. Any questions so far? Okay, now what I need to do is draw a picture. And it's the same picture we always have. So we have a normal curve. So that's a good question. So let me answer that, whether you're going to guess P a little later. Okay, this example, we had a P, but then we'll talk about not guessing P. So good question, and we'll get to it, I promise. That's going to be the next part of this question. Okay, so here we go. And now we know that we want a 95% confidence interval. That's 0.95 as an area. So this area is half of what's left, or 0.025, right? If you have 95% inside, 5% is outside, 2.5% is to the left. And this right here is Z. Any questions on that? Okay, so now I'm going to go to my calculator. And I am going to just go second distribution. And we're going to do inv norm because we're given a percent and we want to find Z. My area is 0.025. My mu is 0 because the standard is a Z, standard normal, and our sigma is 1. And I paste, and I hit enter. And I get about negative 1.96. And the negative doesn't matter because we're going to square that also. So you can ignore the negative. So now we're ready. So Z is the hard part on this one. Okay. So now what we can say is Z, which we now know, is equal to -1, or you don't need the negative, 1.96. And that gives it to us. If we wanted a different confidence level, we'd have a different value because it wouldn't be 0.95. But the way we got that 0.025 is the same idea. You'd subtract from 1 and divide by 2. And just give you a warning on tests. I give you some weird number for a confidence level just to make sure that you can draw this picture and understand it. So don't even think about memorizing the Z. That's not going to work. Instead of understanding how I got it. Okay, and then the rest is simple. Now we just plug in. So let's go and write it out. So we can say N is equal to P, which is 0.52, times 1 minus P, which is 0.48, times, and now we're going to have Z, which is 1.96, divided by E, and E was 0.03. And then I'm going to square it. Any questions on that? Okay, and you can pop that in your calculator. This isn't fancy calculator work or anything. I'm just going to stick it in Google. 0.52 times 0.48 times, we'll parentheses 1.96 divided by 0.03, and then square. And it gives me 1065.4. So let's write that out. This is the one case where we don't follow the rules of rounding. You always go up. So even though it's 1065.4, I'm going to round to 1065 because you want to make sure that you get that estimate. So you want me to Z on the calculator? Let me just write this down and then I'll do it. How's that? So now what we can say is survey 1066 students. Okay, so let me go back to my calculator. So Jeremy, you can see what I did. So what I did is I went second distribution. You've done that before. And inv norm, you've also done that before, right? We did that in chapters 6 and 7. And then the area was 0.025 because that's what I found that value to be in to the left. Mu is always 0 and sigma is always 1 because we're finding Z, not X. And then I hit paste. If you had the older style of calculator, it's just going to say inv norm with a paren, and then you're going to type in 0.025, comma 0, comma 1, and the paren. And it'll look just like this, except without the word left. I don't even talk about left, because most calculators don't have that. And then I hit enter, and there it is. Jeremy, does that make sense? Okay, so now comes the answer to Pooja's question. But I need to wait until I need to finish this first. Okay, so next question. How about a different color? How about black? Okay, suppose that you didn't know about the other survey. How many people must you survey? Okay, for the same question, with a margin of error of plus or minus 3%, 95% confidence interval. Okay, so for this one, it's actually a different formula, but only slightly different. Actually, I'm going to use text, it's prettier. So when we're talking about not having any estimate for the population proportion, which comes up a lot, what we're going to do is we're going to use 0.25 or 0.5 for that. And the reason for that, you don't have to know the proof of this, but this is actually a parabola in P. And P equals a half is the vertex of the parabola, that's the highest point. So again, I wouldn't ask you about the vertex thing, but that's what's going on. So N is equal to, it's no longer a half times, P times 1 minus P, it's a half times 1 minus a half, which is 0.25 times Z over E squared. So that's the formula when you don't have any estimate for the proportion beforehand. So the nice thing is it's a little easier actually, because we don't have to deal with P and 1 minus P, we just have that number. So we have the same Z, we have the same E, we can just put in a calculator now. And what I get is 1,068. So in particular, N is equal to 0.25 times 1.96 divided by 0.03 squared. That is equal to 1068. Okay, it's actually 1067 point something. Let me find it. 11111, but round up, and it's 1068. So in that case, we need to survey a little bit more. So survey 1068 students. Any questions at all on these examples here? Any questions? All right, so next, I'm going to do another example that's going to be slightly different, but it's still going to be about confidence intervals, because that's what this chapter is all about. And let us do that. It's got to let me do that. Let's try this. There we go. Sometimes it's not happy about letting me select. Okay, so now I'm going to give you an example, just kind of one that I had out. All right, let's suppose that you want to estimate the average amount of chocolate Americans eat per year. You survey 64 randomly selected Americans, find the average 12 pounds of chocolate consumed each year, and their standard deviation was 2.8. And let's calculate, just for fun, how about a 90% confidence interval? Any questions on the question? Okay, how is this very different than the last one I did? What makes this very different? And it is important that you can spot the difference. There's a main difference. Any questions? I mean, any thoughts? Standard deviation, yeah, kind of, but not really. Any thoughts? Should I tell you? Okay, the big difference, average, that's all kind of part of it, but the main thing is that this is quantitative. The last survey question was yes, no. This is not a yes, no. right? The survey question I would ask you is, how much chocolate did you eat this year? And you're going to answer, I don't know, 14 pounds of chocolate I ate. Does that make sense? And when you have a quantitative survey question, then we're going to do things a bit differently. Any questions so far? Okay, next, is this a large enough sample size to use the normal distribution? What do you think? Yeah, how come in this case? The key is quantitative. Yeah, now it's greater than 30 because it's quantitative. N is equal to 64, which is certainly greater than 30. Any questions on that? So the distribution is approximately normal. Any questions on that? Okay, now there's a problem. According to the central limit theorem, what you could say is the sample, the mean, we can assume is 30. That's what we're starting with. But the standard deviation, we only have the sample standard deviation. Do you agree? And because we only have the sample standard deviation, the central limit theorem doesn't tell us what the standard deviation of the sampling distribution is, or the standard error is, right? We had that sigma over root n formula, but we don't know sigma. Do you agree? We only know s. Any questions on that? Okay, because of that, we're going to have to make another approximation. And this was actually, believe it or not, this was done because of beer. Okay? And it turns out there was this guy that was working for a brewery, and he was a statistician for them. And he realized that using the normal distribution didn't work because you don't know the standard deviation. So he actually came up with the math to figure out how to make this work. And the mathematics says don't use the normal distribution, use what's called the t distribution. So I'm going to draw something. I'm not a perfect artist. It turns out the t distribution looks almost the same. So this is t and not z. But it is important that you know it's t, and I'll show you why in a bit. Any questions so far? Okay, so now let me write something down just so I don't forget. So we have n equals 64. We have x bar equals 62, equals 12. And we have s equals 2.8. Is that clear? Okay, so now what I do is go to my calculator. And I am going to go to stat. That's going to be the big button. And I'm going to go to tests. And then I'm going to go to t interval. T because we're using the t distribution, and then interval because we want the confidence interval for a population mean. Then I hit enter. And then it's going to ask you the things that ask you, do you have data or do you have stats? We have statistics. Oops, lost it. One more time. We have statistics. That's better. It asks us for the x bar, and x bar was 12. Oops, 12. It asks us for s, and that was 2.8. It asks us for n, which was 64. We wanted a 90%, so I'm going to go 0.9. Any questions so far? So let me hold this a bit because last time I went too fast. So I'm going to take a look. These are all the things that you do. And again, you just kind of follow the menu. Then I hit calculate. And there it is. 11 point, I got one decimal. How about 11.4 to 12.6? Any questions on that? Okay, so now I'm going to go back. And let's write our conclusion. And it is, let me do this, with 90% confidence, it can be concluded that the population mean pounds of chocolate consumed each year or per year by Americans is between 11.4 and 12.6 pounds. Any questions on this example? Any questions? Easy enough? Okay, so now I'm going to do something that you probably wouldn't normally do, but I'm limited today. And that is, I'm going to ask you guys a survey question, and we're going to find a confidence interval based on that. Sound good? So I'm going to erase this. So here is the survey question, and you have to answer. Here's the rule. You have to answer. You don't have to tell the truth, but if you lie, you have to give a reasonable answer. I just need numbers here. And the question I have for you is, how old were you when you experienced your first passionate kiss? So you have to type it in the chat box. How old were you? And by the way, the chat box isn't something that gets recorded on YouTube. But again, you don't have to tell the truth, so no one's going to quote you on anything because, but if you do tell the truth, that's fine too. Okay, so how old were you when you experienced your first passionate kiss? I need all four of you to answer, otherwise we can't do this. And maybe I'll leave an answer too, because our sample size is really small. And again, you'd never do something with a sample size of 5 people, but we got to do it because it's all we got. So and we still got one more. Can you type in the chat box? I won't even say your name so you can be private. All right, looks like you're not paying attention, which isn't so good, by the way. If you don't pay attention, it's going to be rough for you because this stuff is hard. Okay, I'm going to make up a number for you. And I'm going to put my own in. I was 13 also, actually. Okay. So we're going to want the same thing. We want a confidence interval. Let's use a 95% confidence interval. And we have 13, 13, 14, 17, 13. And let's do it. So I'm going to go to my calculator. And we are going to go to stat. Now I'm going to go to edit. I'm going to go to L1 and I'm going to clear it out. I'm going to put the numbers into L1, which is 13, 13, 14, 13, and 17. Any questions on that? Then I'm going to go back to stat. I'm going to go to tests. And this is still a t-test. The t-interval. Because it's the same idea. We're looking for a mean, right? This is quantitative. And that's a t-interval. And we want a confidence interval. So now I go ahead and hit enter. I now have data. So I'm going to hit enter on data. My list is L1. So I'm going to do, even though it's there, I'm going to do it just to say I did it. I hit L1. Frequencies 1 is fine. Confidence level, I want 0.95 this time. And let's go calculate it. Okay. So we get 11.8, 16.2. Any questions so far? Okay, now let's go back. And let me go to the new share. And let's type out our conclusion. So with 95% confidence, it can be concluded that the population mean age of first passionate kiss is between 11.8 and 16.2 years old. Any questions on that idea? Any questions? All right, so you might look at this and you say, well, this is kind of ridiculous because we only had a sample size of 5, right? Any questions on that? Okay, so I have another question. And here's the next question. If you want a, let's say 92% confidence interval, with a margin of error of no more than, let's say instead of, we got a huge margin of error here. It's like years of margin of error. How about no more than 1/10 of a year old? And if we know the standard deviation is, and now I'm just going to look at what the standard deviation was. You won't see what I'm looking at. It's going to go to the calculator. The standard deviation was 1.7. I don't know if you remember, but that's what the calculator said. Ah, lost it. $1.7. How many people must be surveyed? Certainly a lot more than 5. Any questions on the question? Okay, you'll notice this looks a lot like the one I did with proportions, but now we're on means. And with means, there's a different formula. So let me give you the formula for means. And that formula is as follows. N is equal to Z times sigma. You know what? I think I need to do this with a brush because it's too many weird letters. So N is equal to Z times sigma over E squared. Any questions at all on this formula? Okay, so now let's do the easy one first. And that is, we know E. E is 0.1. There's two easy ones. We know sigma is equal to 1.7. Now we just got to find Z, and we've done this before, this kind of way of doing it. So now I'm going to draw the picture. Beautiful picture. And what we know is we want a 92% confidence interval. Okay, so the question I've got is how many are there, what percent, or what's the proportion on the left? What's the proportion on the left if the inside is 0.92? Can any of you compute that? Let's see if you can. Yeah, 0.04, because if there's 92% inside, there's 8% outside. Half of that is 4% on the left. So 0.04. We want Z. So I go to my calculator. And what I do is I say second distribution, imp norm. We've done this before today. And now we want 0.04. And we hit paste and enter. And you get about negative 1.75. And the negative doesn't matter, we're squaring it. So now let's go back. And we can say that Z is equal to 1.75. And again, you can ignore the negative sign, and it's just easier to write if you ignore that. Any questions so far? Why is Z instead of T here? And the reason is it's all we've got. That's a really good question, Pooja. And here's the answer. We're going to get a big sample size. That's something I promise. And if you get a big sample size, then Z and T are basically the same. When you have small samples, you got a big problem. But with a big sample, then it's not a problem. That's a really good question because technically it's T, but it turns out that it's safe enough to use Z as long as you end up with a pretty big sample size. And let's find out what the sample size is. So really good question. So we can say N is equal to the 1.75 times sigma, which was 1.7, and then divided by E, which is 0.1. And we're going to square that number. Okay, and that's calculator work, and it's basic calculator work. So I'm just going to do that on Google, and I'll let you do it too. Nothing fancy about this. You got to remember your parentheses. 1.75 times 1.7 divided by 0.1 and the parentheses and square it. And it gives me 885.0625. Let's write that down. So how many people do we survey? $886, always round up. So survey 886. Any questions on this? Any questions? Okay, so that's about what I need to say, but I need to tell you what the secret word is. Maybe I'll do it in green. And the secret word is population. Because when you're talking about the confidence interval, it's not a confidence interval for the sample, it's a confidence interval for the population, whether it's the population proportion or whether it's a population mean. And I will take off points if you forget that word population or don't refer to the population with things like, for proportions, you could use all. For means, you need to have the word population. And you'll see I actually have that. Right there. That's always going to be in the sentence. Okay, that's about all I have to say. I want to mention a little about the project, but I don't need to be looking at the whiteboard for that. So just a note for the project, I bet you can guess what's one of the things you're going to have to do for project 2, given what we did today. You got to survey, that's true, but actually not necessarily survey, confidence interval. Level, yes, but interval is the biggie. So you're gonna have to find a confidence interval. You're not quite ready to start yet. And it turns out you don't have to do a survey, you have to get data. This is very different than project 1. You're not gonna have to do a stratified sample or anything like that. That was for project 1. For project 2, it's gonna be however you wanna get the data, as long as you can't get the whole population, you can only get a sample. Okay, if you can get the population, there's no reason to do a confidence interval. You're not ready yet because there's next week, which is hypothesis testing, and then the following week, which is about 2 samples. And we're actually going to be talking about 2 samples or 2 populations. Okay, so just let you know, but I wanted to kind of give you kind of a heads up, you're going to have to do a confidence interval. So that's all I have to say for new material. But I'm always happy to answer any questions if you have them at the end of the webinar. Next week's webinar is going to be on Tuesday. Just let you know, if you happen to live in Tahoe, our college is completely closed Friday through Monday because of the holiday. I'll be online still, but that's why I don't do I make sure that we have a Tuesday webinar instead of a Monday webinar, because I like to honor the holiday. Okay, so, but if there's any questions, let me know and I'll help you out. And if not, we can say goodnight too. So any questions? All right, good night, Jeremy. Okay, good night, Kaladin. Any questions, Pooja or Shane? Sure. If you want to go over the discussion posts, let me share that just a second. I think it's here and here and here. So you mean the one that's due this week, right? Is that what you mean?
Oh no, the one I posted on the Q&A, sorry.
Oh, okay. So different discussion post.
Sorry
Yeah,
about
yeah,
that.
there's a lot. Did you know I answered you?
Oh, you did?
I'm very quick.
Oh shoot, no. I didn't see.
Literally, but we can still look at it.
Okay, sorry about that.
Literally, I finished 1 second before I was supposed to start this webinar.
Oh, okay. I think when I checked, you hadn't. Okay.
So the idea here is you asked for a sum.
Okay.
You had that capital sigma, that's summation. Do you remember that from last week?
Mm-hmm.
And when you have that, there's a formula, and the formula is to get the mean. You take the population mean times the sample size.
Okay.
To get the standard deviation, you take the population standard deviation times the square root of the sample size. I don't know if you remember those formulas happened.
I believe so. I think I took it in my notes for the proportion.
Uh-huh. No, this is not proportion. This is for sums or totals.
The CLT for sums.
Yeah, this is
Okay.
the confidence. This is the central limit theorem for sums.
Okay, got it.
Okay, so the idea here, the sample size was 40, and the mean was 44. Standard deviation was 19. That was given in the question, right?
Right.
So the mean for the sums will be 44 times 40.
Oh, okay.
And if you do 44 times 40, you get 1760.
Okay.
And the standard deviation for the sums will be 40 times the square root of 9. Oh, you know what? I got this backwards. Oh, let me fix that. Good thing I noticed it because it's not right. It's the other way around. It's 19 times the square root of 40. That's what happens. I was trying to go real fast so I can make it to the webinar. And then if you go 19 times square root of 40, you get 120.166551.
Mm-hmm.
Okay, in fact, I'll go 166 is good enough. 4 decimal places is always enough. Okay, so what you can say is that now I need to go to this guy. And let's go Greek. And let me go find that sigma. There it is, sigma, tilde, n, and then our numbers were 1760, comma, 120.1666.
Got it.
Because that's what they wanted.
Okay, perfect.
Oh, it didn't give the tilde. I hate that. It's always hard to get this tilde in. I think it is. Oh, wait, slash. No.
Is it tilde with the A?
Yeah, my spelling's not as good. Did that work? No, that still didn't work. Well, I'll do it this way. One more way of doing it. I could go look it up, but I can do it this way, and then this way, and then this way, and then this way. Sigma n, yeah. How about sum of nothing? That's better.
Got it. So that that E symbol, that's just pretty much saying the sum.
Yes, yeah. That was that's the math symbol to say add them up or find the total or find the sum.
Okay, so it's not necessarily saying to add them up, but to like to find the sum because we are multiplying to find the mean and the standard deviation.
Yeah, but remember the word sum means add them up.
Okay.
It means if you were to add them up, then the distribution of adding them, of what you get after adding them up is that. You see? But that's the same thing as the distribution of the sum is that.
Okay.
Does that make sense?
Yeah.
Okay, so it's, and that's it. It's a formula.
Okay.
Any other questions?
Thank you. No, I think that was it. Thank you.
All right, well, then we'll say good night. And for all of you watching this as an archive webinar, have a good night, and I'll be checking the forums, the discussion boards. So please post any questions you have, and make sure you look at my sample post, because that will help you on making your post happen and happen correctly. And also at this point, you should be working to find a proctor if you haven't already found one. And if you can't find one, let me know. You can email me, and then I'll help you find one. You just have to tell me what city you need to take the test at, and then I'll help you find a proctor. Okay, but again, the places that most people go are their local college and their local public library. Those are the two biggie. And you're going to have to show a picture ID to be able to do that. Okay, so have a great one, and I'll be happy to work with you this week.